The last part from day 3 will be the problem about velocity and acceleration. The first thing I want to talk about is how they are related. In previous lessons, we have learned that S of t stands for the position function. We also learned in previous lessons that the derivative of the position function equals the velocity. Now, this lesson, we're going to learn that if I take the second derivative of the position function, which would be the first derivative of the velocity, that equals my acceleration function. I need to know that before I can complete this problem. The first question in this problem is to find the velocity of the object when t is 3. I can do that simply by just plugging 3 in for t. I was given the velocity equation, so I can just go ahead and plug in 3. So the velocity when t is 3 ends up being 36 minus 9, which is 27. The label for this is meters per second. Velocity is always feet per second, meters per second, whatever label we're talking about, so distance over time. What I just got through saying was that if I took the derivative of the velocity, I would end up with acceleration. So that's what I'm going to do. I'm going to take the derivative of the velocity, which equals my acceleration function. The derivative of 36 is 0, and the derivative of negative t squared is negative 2t. I'm going to find the derivative at 3, or the acceleration at 3 by plugging in 3. I end up getting negative 6, and the label for acceleration is always meters per second squared. I shouldn't say always meters per second squared. I should always say it's distance over time squared. The last part of this question asks me, what can be said about the speed of the object when the velocity and the acceleration have opposite signs? In order to answer that question, I'm going to bring up my other slide. On this slide, it talks about how acceleration and velocity are related. So if I have positive acceleration and positive velocity, I know that it's getting faster in the positive direction. Negative acceleration and negative velocity tells me it's getting faster in the negative direction. Positive acceleration and negative velocity tells me it's getting slower in the negative direction. And negative acceleration and positive velocity tells me it's getting slower in the positive direction. So if I go back to the problem that we are working on, you can see that I have positive velocity and negative acceleration. Having different signs always leads to going slower. So I know that this is getting slower. In which direction? The direction depends on the velocity. So it is getting slower in the positive direction. And that is it for day 3 of lesson 2.3.